All right, good afternoon, chemistry class. This is Coach Jeans, and in this video, we're going to talk about types of chemical reactions. Now, there are a lot of different types of chemical reactions, too many for us to try to learn in a first-year chemistry class. So there's basically some basic ones, 5 types of chemical reactions that I want you to be able to recognize. And so if you understand like the general format and find the pattern there, you'll be able to identify these chemical reactions. So the first one is called a combination, or sometimes called a synthesis reactions. And in a synthesis reaction, what you basically have is you have a element or compound plus another element or compound that forms just one single compound. So it's like A plus B gives you compound AB. So the key here is on the right-hand side of your arrow, on the product side, you have only one thing formed, one compound. So here's some examples. Calcium oxide reacts with carbon dioxide to form calcium carbonate. Or we have mercury plus oxygen gas gives you mercury oxide or mercury 2 oxide. And one of the analogies I like to use in class is the dance analogy. And so it's kind of a corny analogy, but it works and it'll help you kind of remember these different types. In a combination reaction, here's how the analogy goes. We have A comes to the dance by himself, couldn't find a date. B, she comes to the dance by herself as well. When they get to the dance, B sees A come in the door. And she says, wow, A sure is looking pretty cool tonight. And A looks over at B and says, I've always thought she was real pretty. And so A finally gets enough courage to go over and ask B to dance. And so then they get together as a couple, and now they are one thing. They're joined together as a couple. All right. The next type of reaction we're going to talk about is a decomposition reaction. And a decomposition is like the opposite of a synthesis reaction. What you have is you have one compound, for example, AB, and it breaks apart into 2 or more simpler substances like A plus B. So like, for example, H2O, water, could be broken down through hydrolysis into hydrogen gas and oxygen gas. Or something like potassium chlorate can decompose into potassium chloride and oxygen gas. So the dance analogy goes like this. A and B go to the dance together. However, they get in an argument and B gets really mad at A and A gets really mad at B. So B says, forget you, A, and A says, forget you too. And so they split apart into 2 separate atoms. The key here is to recognize these by it only starts with one reactant, one compound, and it breaks apart into 2 or more simpler types of substances. All right, next is a single replacement reaction, or sometimes I'll call it a displacement reaction, but I think the book calls it a replacement reaction. So these are single replacement reactions. The general format here is A plus compound BC, so you have a single element plus compound BC, gives you the the compound AC plus a single element B. So what happens is A removes and displaces B and kicks B out and forms the compound with C. So an example here is that you have iron metal and it reacts with silver nitrate, and then the iron replaces the silver to form iron nitrate and silver metal. So how's the dance analogy go with this one? Well, this one goes like this. B and C go to the dance together, and A goes to the dance by itself. Well, C sees A and says, wow, I think A is a lot more attractive than B. So C drops B and hooks up with A to form the compound AC. And B gets kicked to the curb and is now by itself. Sad story, but that's the way elements do things. All right, next one is a double replacement reaction. In a double replacement reaction, we have 2 compounds on the left-hand side, and it forms 2 compounds. So 2 means double, so this is like a double-double. So 2 compounds, AB plus CD, and then when they react, they are rearranged, and A bonds with D and C bonds with B. So an example would be a compound like barium chloride plus sodium sulfate, and it forms barium sulfate plus sodium chloride. Notice what happened is the cations, the barium and the sodium, switch partners, don't they? So sodium bonds now with the chloride and barium now bonds with the sulfate. So how does the dance analogy go with this one? Well, A and B go to the dance as a couple. C and D go to the dance as a couple. When they get to the dance, A looks over and sees D, and A says, I've always liked D. And D looks over to A and says, I've always liked A. And so they work it out where they can get together. And so A and D get together, And in the meantime, C and B are left alone, but then they said, hey, we might as well get together too. And so they form a couple as well. So kind of a silly example, but it works. All right, the fifth type is called a combustion reaction. Now, luckily on this one for you that I don't have a dance analogy for a combustion reaction. Basically, it forms like this. To recognize these, you take a hydrocarbon. What is a hydrocarbon? Well, it's simply what the name tells you. It's a hydrogen and carbon compound. And when you take a hydrogen carbon and you react it with something like oxygen gas, or you react it with oxygen gas, you'll form carbon dioxide and water vapor. Now, this would be a complete combustion reaction when it completely reacts. And the key here is you recognize that you have something plus oxygen gas. And remember, that's always O2 because oxygen is diatomic. And then it always forms the same two products, carbon dioxide gas and water vapor. So those make those easier to recognize. So here we have something like CH4 methane gas, which is natural gas, burning or reacting with oxygen and forming carbon dioxide and water vapor. Excuse me. And so this is anytime you have something burning, it's a combustion reaction. So this is what happens like in a chemistry lab when we light a Bunsen burner. We have natural gas, which is CH4, and we're reacting with the oxygen that comes from the air. And the products are, again, are carbon dioxide and water vapor. Remember, it's a water vapor. And then you have this one right here. This is methyl alcohol. And methyl alcohol will burn. When it burns, it's reacting with oxygen gas in the air and forming, again, carbon dioxide and water vapor. So that's about it for that. So take notes on your worksheet. You'll be asked to identify some types of reactions, and you should be able to do that fairly easily. All right, see you next time.